Welcome to the tutorial video for the auto-labeling tool. In this video, you will learn how to create annotations automatically without to draw them. The advantages to use this tool are the time you will save and the detection of the objects that will be improved. At first, before to use the auto-labeling tool, we need to open AccuPick and create a project. Inside the capture block, conduct the necessary camera calibrations, then fine-tune the settings to obtain the best possible image. You can go to the 3D tab and crop the point cloud, considering the upper and lower limits in X, Y, and Z vector. For this project, I'm going to use instance segmentation in recognition block, because I want to classify between two kinds of classes, front and back side. I need to open input image to select the ROI. Also, I need to establish a lower and upper limit for the Z vector. We recommend to capture one image with the bin empty and different more kind of images with the objects inside the bin. Select the entire image set and send it to the training list. We can open the folder where the project was created. And inside the Deep Learning Tool 0 folder, I'm going to create an extra folder to put there the results from the auto-labeling tool. Proceed with the installation of the latest auto-labeling tool. For that, run the installer and copy the path that contains the latest Blender version. We recommend to use 2.83. Proceed with the full installation. Please check that all the objects are selected inside that list, and once this process has finished, then open Environments folder. Inside this list, you will see a set of environments that has been installed due to the auto-labeling tool. Copy the path of the folder where we are going to put the results of the auto-labeling and open Blender. Then we can go to Edit, Preferences, and in Add-ons, please check that 3D View Solomon Simulation is selected. If not, please select and close. The indication that you are working with the auto-labeling is with these two tabs, Config tab and Solomon tab. First, click in New Project, and here we are going to paste the path previously copied. Press Enter, and then New Project. This process will be conducted as Guru mode, where we are going to see all the configurations inside auto-labeling. Also, don't forget to save the configuration parameters. And inside the auto-labeling tool results folder, you will see a set of files and new folders that were automatically created by the software. The background, environments, and objects folders are empty, so we need to add the necessary files to each one. In my case, I already added. Inside background folder, we can paste all the images with the objects inside the bin or the objects over the platform where we are going to pick. Please don't consider to add the image with the bin empty. Inside the environments, we can paste the environments that we can copy from the environments folder inside the main folder of Blender program, exactly this folder. Inside objects folder, we can paste all the CAD models. Please consider that it's an obligation to use OBJ files only, otherwise auto-labeling won't work. You can also add MTL file or PNG in order to add the texture for your CAD model. Okay, now we can start with the project. Inside the project panel, I have new project icon that will help me to create a new project as you saw before. Import config file that will help me to call the project and save config parameters will help me to save the current configuration, and the show project information that will help me to see the path of the project I am working in this moment. So now I'm saving. I'm going to reset Blender to reestablish the parameters to the original status. In that sense, you can see when I open the project again, the parameters will be modified as how I said before I have closed the project. This is how I can continue working on my project based on the last status of the parameters. Now I'm deleting the object and I'm going to import the project. I need to paste here the path where my project is located, select config JSON file and import config file. Now as you can see, the status of user mode changed to guru mode. Before it was beginner, which is the original status. In the same way it will work with the rest of the parameters. There is another way how we can save the project. For that I need to go to file, save, and this process will save the file as blend file. So I need to paste the location of the project, then I can give it a name. In this case I'm going to use the same name as the folder, auto labeling tool results, and then we need to press on save Blender file. Now we can close Blender, and if I open the folder of the location of the project, then I need to open always with administrative permits the blend file. It returns to the previous point of the project. The optimal solution for my case doesn't need to be the same as the optimal solution for yours. It is because of the conditions that affect the kind of image you have. To briefly enlist them, you may focus on light conditions, the color of the object, how the color of the object changes with the projector light, as well as from the external light, if the image was taken with or without a grayscale, the texture and the material of the object, the reflectivity of the object, and many more conditions you need to consider. Please put close attention to the mentioned conditions, which are not going to be the same for every project. Therefore, the way how I'm going to configure the auto labeling tool doesn't need to be the same or the optimal for your case. The objective of this tutorial is to demonstrate how to use the auto labeling tool. We have the camera, a light, a background image which is going to appear in the center of the workspace, and the CAD models. I have selected the camera, and if I select this icon, I will see the point of view of the camera. I have also a light which is represented with this icon. And if we open the render settings, we can see we are going to generate the simulation as bin mode, where we are going to throw the objects over the bin. We are going to generate 10 images, just as an example, and we are going to start from the index 0 until we have 10 images. The format of the images we are going to generate as PNG, and in the simulation we are going to consider the last frame in the video, which is going to be the 50th frame. The metric we are going to use for all the objects will be in millimeters. About the background settings, we can see that the background shading has been selected, which means that the light is going to influence the background image. In that sense, the shadow of the objects is going to affect also the background image. In work settings, here we're going to work with the set of environments we have copied to the environment folder. Each image will contain a different environment. It is determined only by the random cycle, but in case you want to work with only one environment, then you need to copy only one from the complete list. In camera parameters, here if we are working with a standard camera, then we need to consider the lens to be always 12, the sensor size to be 9.2 as the upper side, and lower side to be 5.8. For the resolution, we need to check the dimension of the background image. For that, I need to open the folder that contains the background images and check the dimension for one of them. In noise level, we are going to add a noise to each image. The percentage of the noise will be stable for each image of 0.2. However, we can establish a range by enabling the second part. I'm going to establish as 0.25. Then for each image, it will be randomized from 0.2 to 0.25. In focus mode, by default is established as infinite, which means we are going to keep the same focus for all the images, and finite when we are going to randomize the focus for each image. In aperture f-stop, we recommend to always use 4 for the standard camera. For this example, I'm going to use infinite mode. The distance from the camera to the image is going to be 1400, will be 90 degrees in contrast to the background image. Take into account that the values we have established for each parameter are useful only for the standard Solomon camera. In case you are using a different type of camera, then feel free to ask the support team for the correct values. In light settings, we are going to use the type point, which is enough for our standard Solomon camera. However, in case the external light conditions influence the type of image you obtain, then you can change to any other type. Only one light should be enough. The light power is how strong the brightness of the light is going to be. In predefined color, we are going to use a white color. Each block represents the RGB color. That's why one will be enough for all of them. And the height range is the percentage we are going to place the light for each image. The range is going to be from 0.5 to 0.7. The total distance of the height goes from the position of the camera to the position of the background image. In class settings, we can delimit the number of classes we can permit to print in each image. Only for special cases, we can declare a limitation for the number of classes. Hence, working with the current setting is fine for general purposes. In wall settings, the user can set up the limits of the walls. This process is optional because not all the times we are going to pick from a bin. Click on Manual Select Wall. A window with the background images will appear. Select any image and draw a rectangle on it, close to the position of the walls. Finally, press F to save or R to reset and draw a new rectangle. Automatically, the coordinates of the limits will be displayed. Now it's time to check the Solomon tab. In Object List panel, we can click on Import Objects icon, which loads the CAD objects. All of them will appear in the center of the workspace with a small scale. Don't worry, the real dimensions of the objects are going to be correct when we run the simulation. To move the workspace and get closer to the object, you can use Shift button plus round icon from the mouse. To rotate the workspace, use the round icon only. To zoom in and zoom out, rotate up or down the round center icon. You can also press 1 in numbers block of your keyboard to automatically rotate the object and watch it from the white vector of the workspace. We can use 3 types of viewport shadings. The actual is the solid, where we are going to see the CAD model without any texture or material. The second is the material preview, where the texture and the material are enabled. And finally, the rendered, where the object will be influenced by the light conditions. This last icon will help us to check the quality of the images we are going to generate. Any physical modification we have applied to the CAD can be saved with the Save Transpose icon. Sample points and voxel size options will be influenced the way how the point cloud of the objects is going to be created. We recommend not to modify these values. Auto Labeling tool uses the point cloud of the objects to check whether an annotation is going to be applied or not. In Object Settings panel, we can declare how many objects are going to be inside the simulation. By default, one object is predefined, but it is up to you if you want to generate an image with an aleatory range that goes from 2 to 9 objects. For every image, the number of elements will be around these limits. But if I change the initial number to be 0 and the second number to be any different number than 0, then I will generate images with only the number of objects declared in the second block. I strongly suggest you to start the initial simulation with one object just to check that the parameters of our simulation are correct. We can rectify the scale of the object if it is too small or too big in comparison with the real size of the objects. As I mentioned before, the simulation consists of throwing the objects over the bin. This action is heavily influenced by the weight of the objects. Here, in mass weight, we can set it up. In 3D workspace, given a finite set of points, it's necessary to calculate the minimum convex polygon so that any point can be computed and analyzed if it is either inside this polygon or at its border. This geostatistical method defines the shape of the objects and its behavior the moment when they collide with another object. We strongly suggest to keep this option named as convex hull for the majority of the cases. Sometimes we have to delimit a specific region of the bin for a unique type of objects. Therefore, limiting the same region where we are going to place the objects in the simulation is a useful method to emulate the reality. Sometimes, the objects we want to pick are going to appear showing only one side of it, for example, only the front side. That is why we can lock the rotation of the object and obligate it to fall showing only one side, like the front side in my example. And as you can see, the origin of the object has the same location of the origin of the workspace. That is why we can see the front side of the object from the y-negative vector of the workspace. I am not going to restrict the rotation of my object because I want to detect front and back side despite of the location of it inside the bin. There are two icons which help us to save the modifications we have applied to the CAD objects. Save single icon will save the modified parameters only to the select object. Save all icon will save the modified parameters to all the objects. In this case, because I have only one object, both icons will do the same thing. In render panel, we have three icons. Solomon animation will generate only one simulation, but it won't generate any image. Solomon generating will generate a set of images based on the configuration established in config tab, object panel setting, key point panel, and class name panel. And reset workspace icon will take out the simulation and it will return the object or objects to the origin of the workspace. Now, let's check the first animation. The simulation is structured with this pyramid that represents the FOV of the camera. One of the background images randomly selected by the auto labeling tool, and the light located at the distance defined in config tab. Now let's focus on the size of the CAD model. As I mentioned before, the size of my CAD is correct. Nevertheless, as you can see, it doesn't seem that it has the same size as the objects in the background image. I did it intentionally because I want to spotlight the importance to declare the correct parameters for each panel. Any small mistake and the result won't be the desired. I know the real cause of the problem, and it is related to the working distance, which can be modified in this section, named as distance capped image. The real distance is 660 millimeters. Now, I just need to save the new setting and create a new animation. If I click on Reset Animation, the background image and the objects from the simulation will disappear and only one CAD model will appear in the center of the workspace, as it was originally. If I repeat the animation, this time the CAD model will have the correct size. There are ways to analyze how big or small the CAD model needs to be. Is it by measuring the pixel size? However, it doesn't need to be exactly the same size. If you can see that the CAD model has more or less the same size of any of the objects in the background image, then it's enough for our purpose. No need to waste much time to measure it. Now, I am changing from the viewport shading to rendered mode to see how the light influences the background image as well as to the CAD model. Bear in mind that the images generated from the auto labeling tool will contain the influence of the light. The rendered mode is the exactly representation of the real images. Apart the light we have implemented to the simulation, we can see the environment now. When I rotate the simulation, we have the complete view of the environment. The reason why we include the environment to the simulation is because it can give us a major variability of the external light conditions. In this example, every time I click in Solomon animation, a new environment will appear randomly, because it's the way I have established previously in config tab. The variability of the external light conditions can be beneficial to improve the detection of the objects because the quality of the images can be heavily influenced by the light conditions depending on the time when we are working with the vision system to detect the objects. For example, if our station is influenced by the light of the sun and we are going to conduct the detection only at night, then the quality of the images we have created are not a good representation for a proper detection. In other terms, the chances we have to detect the objects properly are reduced. An alternative situation could be when you are using the projector light of Solomon scanner as light source for the images you are taking. In that situation, we can consider to use an unique type of light for each image. In this example, I am using the projector light as source. For that reason, I am not going to use the external environment. I will concentrate only to imitate the influence of the projector light to the objects to be as much similar as it can in comparison with the real images. We can play the video of the simulation and analyze how the objects used to fall over the background image. This process will help us to verify if the conditions we have estimated are the correct, and in case the project requires, we can rectify them. In Config tab, we left 50 frames as default to capture every image. For the majority of the cases, 50 frames should be enough to have all the objects well placed close to the background image. You can modify this value, but the bigger the frames of the video, then the computational time will be also higher. You can stop the video at any time. It won't affect the moment when the auto-labeling tool will capture the image, because it is predefined to be at the last frame. Now I just need to reset the workspace and disable the influence of the external light which origin is coming from the environment. By opening Config tab and inside Background Setting, disable the option Background Shading. In World Settings, disable Random Environment to stop displaying the environment. Save the configuration and run the animation again. Now our background image has the original color without the influence of any external light. My new objective is to imitate the real color of how the light from the projector is reflecting to the objects. To do it, I need to select the cat object in the Object List panel, and in Material Properties tab, in the section Surface Color, select the option RGB and pick out the eyedropper icon. This tool will help you to copy the RGB color of the selected pixel. Therefore, I recommend to copy the color of the pixel that represents the average color of the majority of the pixels of the objects. This color needs to be in the middle of the color clarity range. In other words, choose a color which is not too dark, neither too bright. In case the selected color is not the most optimal, you can select another pixel or slightly modify the selected color, like I am doing by increasing a little bit the clarity. Once you are sure that the selected color is the best option, then you need to remember the RGB code for each section. Before to continue, you can return the RGB values to 0 for all the sections because we are changing the color of the surface of the object and we don't want to modify the object. We want to adjust the light to display the correct color. In my case, the texture of my object has an image of the real object as surface, so doesn't matter the RGB color of the surface it has. The CAD model will always display the image as the texture, but in your case, if your CAD model doesn't have an image as texture, then I strongly suggest you to change the RGB to 0 as it was by default, because having the real color of the object already incorporated to the CAD model in addition to a light that displays the same color will strongly influence the way how the color of the objects will appear in the simulation. My suggestion is to consider only one option among these two possibilities to include the real color of the objects to the CAD by attaching it as surface color of the CAD or by linking to the color of the light, but not both at the same time. In this example, I am using both at the same time because I am sure the color selected in Surface Color panel won't be displayed because I am using an image as the base of the texture of my object. Regarding the configuration of the texture and the material settings of the CAD models, please feel free to consult on internet where you will find a big variety of approaches and methods how to configure them properly. This section is not exclusively part of the auto-labeling tool. with the RGB color in mind, we have to open Config tab, go to the light settings and input the code with the same order in predefined color. Finally, save the modifications and create a new animation. If I change to rendered mode, I will be able to see how the real image will appear. Now, you can appreciate how realistic is my CAD model, comparing with the rest of the objects. But still, we have the yellow outline around the CAD object, because it represents that we are selecting this object in the workspace. So, I can press F12 and automatically a new window will appear with the real image generated from the auto labeling tool. This is the best way to analyze how realistic is our simulation. You can see that the CAD model is in the center of the image, and due to the parameters I have explained previously, it seems to be part of the image. Now it's time to establish the way how we want to declare the annotations for this project. As I mentioned at the beginning of this tutorial video, I want to classify between front and back side of the object. Then I need to consider two classes. The reason why I need to add the key points to the object is due that the annotation needs to have the deep learning angle. As you have seen from the tutorial videos of AccuPick as from the manuals, the deep learning angle known as DL must be declared to state the correct direction of the X vector of the pick point in AccuPick. Therefore, we need to add 2 points which are going to represent the initial and the last position of the DL angle. Remember that in this example, I only use the X vector of the workspace as a guide to establish the orientation of the DL angle, but in other situations, you can use the DL angle pointing to any direction. Take into account that you can use the same 2 key points for more than one annotation. Click on this icon named as cursor, then click here. And this is the initial position represented by number 0. The second position of my DL angle will be this one, which is represented with the number 1. Finally, I can save the key points. If I forget to save them, the key points will suddenly disappear and you will be obligated to declare them again. Give the names of the annotations in class name panel. The first one will be front, the second will be back. The subsequent part is one of the most important to put the annotation into the correct place. To understand it in better way, I'm going to rotate the object a little bit to have a better view for each direction of the workspace in contrast with the object. If I open this list, you will see 19 possible point of views. Each point of view starts from the camera to the origin of the object. You can see the 3 main principal arrows, which X is red, Z is blue, and Y is green. All these 3 vectors are positive axes starting from the origin. The front side will be considered the part of the object which has the words on it, and the back side will be the opposite side. Following that logic, the point of view of the front side is coming from the inverse side of the Y positive vector. Then the proper way to state this annotation is by selecting Y and inverse. The same logic I need to apply for the back class, where I need to consider the positive side of the Y vector. You may wonder how to recognize the point of view of the rest of the options in the list. For that, I need to rotate the object and watch it from the X-axis point of view. Therefore, you can see the 8 point of views located around the current position of the object. Similarly, you can see the same from the Y-axis point of view, in the same way as with the Z point of view. With that, you have a better idea how to establish each direction. Concerning about the direction angle, I am going to rotate the object to show you graphically. I can define it as an aperture in degrees starting from the origin, which opens an angle from the selected point of view or the selected vector. This angular aperture can be represented as an infinite ice cream cone. The area inside this imaginary ice cream cone is the one used to paste the annotation. As an example, I can represent an aperture of 22 degrees. Then the ice cream cone will look like this. But I suggest you not to estimate a small angle, because if the camera cannot visualize the object from the area of the 3D ice cream cone, then the annotation may not be pasted, because the area of the ice cream cone is too narrow. The direction angle for both classes will be from 0 to 60 to be sure that the area is big enough to cover each face of the object. The angle vector is the DL angle. As I said before, the DL angle will go from 0 to 1, and I can input that information here, where the first block is the initial location and the second block is where the DL angle ends. In this case, I am going to declare the same direction of the DL angle for both classes. In the next section, we can decide how many key points we want to display for each class. The option only is useful when we have created a big quantity of classes, and for each class we have a unique pair of key points. If we decide to print all the key points with the CAD model, then the moment when we are generating the image set, it could be a mess, because our objects will have a lot of key points around and over them. That is why it's much better to select the option only and determine only the pair of key points that we are considering for that class. I will leave it as all. The object visibility is measured in percentage. It goes from 0 to 1 and is the percentage of the class that is visualized by the camera. This function helps us to determine a limit for the auto labeling tool to apply or not the annotation. I suggest you to establish with a high percentage. I am going to declare it as 70%. Therefore, if at least 70% of the object can be visualized by the camera when the image was captured, then the annotation will be pasted over the object. Nevertheless, if less than 70% of the object is visualized by the camera, then the annotation won't be applied over the object. There are two scenarios where the object can be presented with less than 70%. The first one, when the object is covered by another object, and the second case, when the object is not covered by any other object or obstacle, but it is tilted that won't allow the camera to visualize the object clearly due to the height inclination it has. At first, you can start declaring these options in class name panel in the same way I am doing in my project, but take into account that there is not a standard way to establish these parameters for all the cases. These parameters are heavily influenced by the shape of the object and the part of the object you want to detect. The first time you are testing with these functions, probably the result won't be the desired. That is why we suggest you to modify them and test several times in the way you consider the most optimal. Later, I will show you how to check the results from the way I have declared these functions. These two classes we have created are going to work with the complete CAD model. For now, if we leave it as that, without touching the functions select mask and mask visibility, then the project should work well. That is why we can save these classes with the same icons we saw in Object List panel. These icons work in the same way. Save single is useful when you want to save this list of classes only for the selected CAD model, and save all is useful when you want to save this list of classes for all the objects that are included in Object List panel. But don't forget to save the classes, otherwise they will suddenly disappear and you will be obligated to do them again. Also, don't forget to save the progress of the project by clicking on Save Config Parameters, located in Config tab. Let's assume you have a special scenario where you need to apply a partial annotation over the object. With the current setting, the annotations will be pasted over the object considering the entire object. So it's necessary to modify the settings to have a partial annotation. In this tutorial, I will consider a partial annotation for the front side, and I will keep the complete annotation for the back side. Then you will have a better idea when and how these two methods are applied. To apply a partial or customized annotation over the object, I need to change to edit mode, and automatically the appearance of the object will be modified, but don't worry. If we return to the object mode, we will see the same object as we had before. The partial annotation will contain the front side of the object, but without the section containing the letters AM. For that, you can use the way you want to make the selection. It can be by vertex, edge, or face. When you click over each icon, different characteristics of the CAD model will be displayed. I can simply select this region and everything will be deselected with the exception of the mentioned region. It's very difficult to select the region of interest accurately at once. I suggest you to select the majority of the region of interest the first time, and for the consecutive parts you can press on Shift plus left click and draw a square. Then every time you draw a new square pressing Shift, then the selected area will be added to the initial selection. Watch out not to press Ctrl because it will do the opposite. It will erase the selection. Another useful shortcut to have in mind is the key A. With it, I can select and deselect the entire object. The selection process may take time to complete. It will depend on the number of faces your CAD model has and the region you want to cover. I suggest you to start selecting the area of interest first with the vertex mode. Once you have reached a point when you cannot select more region or is difficult to continue the selection, then you can change the selection mode to face. And by holding Shift button, click in the center of the face to add that specific face to the selection. To make the things simple, you can also select an area with the left click jointly by holding the Shift button, and thus you can add various faces at the same time. Take into account that the area I am selecting now is not the one I am going to use to place the mask or the annotation over the object. This area is the one I don't want to consider. Then we need to change the selection and thus focus on the opposite part of the object. We can do it by using the shortcut Ctrl-I. The selection process is better to conduct by focusing on the smallest area due to the time it takes to select the biggest area despite of the real selection we want to achieve. Because if the selected area is not the one we want to consider to place the mask or annotation, then we can simply change the selection and focus on the rest of the area by inverting the selection. Notice that I already have inverted the selection, but I also have included the back side of the object, which belongs to the undesired area for the mask. To select this area, keep pressing Ctrl button and with the left click draw a square that will cover the undesired area in order to deselect it. The orange color represents the area I have selected, and now it is correct. It's time to establish it as a mask for the front class. For that, I need to select the opposite area of the selection with Ctrl-I again and press on X that opens the window of the delete options. Select the most appropriate option to delete the selected area. For the majority of the cases, the option faces will be fine. Now the specific area of the front side as well as the complete back side have disappeared, and we have only the desired part of the CAD model where we want to paste the mask. You can notice that there are certain areas where the object remains linked, keeping a form of a disk. This is not acceptable for the purpose we want to achieve. In order to solve this problem, I need to bring the deleted section of the object back with the shortcut Ctrl-C. After that, I can finish the selection process by completing it with the sections that were not considered before, and repeat this process until I can obtain the desired result. With this cropped CAD model, we can give a name to this mask. I suggest you to give a name using the name of the class as a root, plus any other extension in order to know the relationship between the new mask and the class. Then, click on Export the Mask File icon, and immediately the customized annotation has been created. We just need to designate it into the proper class and apply a percentage in mask visibility. It is the minimum acceptable percentage to make the subclass visible over the object, considering only the selected area. This percentage works in the same way as in object visibility, but instead of considering the complete object, this time we'll consider only the area we have estimated as a mask. The type of percentage you can estimate will vary depending on the shape of the object and how big the annotation is in contrast with the class. As general rule, you can start with a high percentage. Take into account that when we are working with a customized annotation, the object visibility is going to be the first applied filter, and after it, the mask visibility will be applied. But for the back class, if we leave it as none, then the mask visibility will be disabled and we can leave it as 0. Now that we have finished with the customized annotation, I strongly recommend to click over any area of the workspace and press Ctrl+C to bring the deleted CAD model again. Be aware that in case you haven't brought the deleted area of the object back and continue working with the cropped CAD model, then the moment when you save the progress of the project, you might replace the original CAD model with a new cropped model. This will result on different types of errors. With the complete object, I can change to object mode and check that everything is correct. If yes, then you can proceed saving the classes. I can close the class name panel and now I can go to the preview converter panel. Here I need to import the classes and subclasses by clicking on the following icon. The names of items we can see were generated with the name of the CAD model and the name of the class we have recently created. The purpose of this panel is to rename the classes and subclasses in order to simplify the name they have and, in cases necessary, mix the classes. For this case, I will use it only to simplify the classes I have created by providing them a new, easier name. In case you want to mix two or more classes into a single one, then you need to move the order of the classes in this list and put them together with these icons. It's extremely important not to use words that don't belong to the English alphabet when you are renaming the classes. Otherwise, AccuPick will have problems to read the annotations. With the icon preview class name, you can check that the names and the location of them in the list are correct. If yes, then you will see a window like this, where each class is encapsulated inside of brackets. If not, then you will receive an error message. If so, please refer to the manual of the auto-labeling tool to check which is the error you are committing and how to fix it. This is practically the last step of the configuration of the auto-labeling tool. Now it's time to focus on the way how we are going to generate the images and the annotations. First, I would like to show you where the images we are going to generate are going to be stored. In the folder where I have created the project, the images will be located inside the output folder. Notice that we need to generate the images and consecutively we have to modify the structure of the files in order to be loaded from AccuPick. Before to generate, I need to add the image of the bin empty inside the background folder. Remember that we have pasted a set of images with the objects inside the bin previously in this folder. It was with the intention to serve as a guide and thus follow them with the objective to emulate the physical conditions of the image. But now we don't need them anymore. That is why I'm going to delete all and proceed to paste only one image with the bin empty. For every simulation I was considering to generate one single object, but now I need to assign the real quantity of objects I will have the moment when I will conduct the picking process. In this case, 25 is the maximum number of objects I will have to pick from the bin. Therefore, the range of objects I will add to each image will be randomly selected from 1 to 25 items. There is not a limit for the number of objects you want to consider for your case. To have a more realistic scenario, it's better to consider the real weight of the object. Don't forget to save any modification applied in Object Setting panel. Due that this is the first set of images we are going to create, I strongly suggest you to start generating a small quantity of images with the objective to evaluate that the results are correct. That is why I am going to generate 10 images only. Also, don't forget to save the modifications recently applied to the project, and let's briefly check with one more simulation that the parameters recently determined have been saved correctly. Yes, is correct. We have more quantity of objects inside the bin. Also, if I check the influence of the light, it should be also fine. Now everything is ready and we can start generating the set of 10 images with the icon Solomon generating. Then click on No and automatically an extra window will show you the progress of the generation process with the respective time you need to wait to see the results. When you are generating the image set, Blender gets frozen and none of the functions of the program can be modified. However, in case you need to stop the generation process, you can close this window to stop it. When Blender is generating the images, you can minimize both windows, the progress window and Blender program, and work on other things while the auto-labeling tool is doing its job in the background. When the generation process has finished, automatically this window will close and the simulation of the last generated image will appear. Now you can use Blender. It is not frozen anymore. The first set of images were generated with the settings of the lower part of the preview converter panel. In output color we have two options. The option color enabled to generate images with the real color from the simulation, and the option grayscale will modify the vivid color to be black, white and all possible tones between them. The crop mode function allows the user to reconsider the region of interest. It is useful when you haven't considered the most optimal region of interest at first, when you captured the set of background images. In that sense, this function helps us to select and restrict a new region of interest. When the option None is selected, then this function is disabled, and thus you will use the complete background image. The option Black Mask will cover with black color the region outside the ROI. The alternative option will help you to crop the region outside the selected area. In this project, I don't need this function, but as an example I will show you how to use it. Select the most convenient option. Then click on Select on ROI icon, and a new window will appear with a list of items located inside the background folder. Select any image and click on the Selecting ROI from Image icon. A window with the background image will appear, and finally select the region of interest. Press F to finish or R to reset the drawn square. I'm going to reset it because I don't need this function, and I will select the option None again. You can estimate the way how you place the annotation over the object based on the configuration of the output mask function. By default, the option Full Mask is selected and it places the annotation considering the complete visible area of the annotation. If the annotation is divided into two or more parts, the option Biggest Area will calculate most of the visible area of the object and will place the annotation over it. Lastly, if the annotation is divided into two or more parts, the option Area Higher Than will consider the limit saddled by the user. The limit will be the minimum visible area required to place the annotation. The user can decide which of the characteristics listed in this section will be displayed for each annotation. I suggest you to keep all of them enabled. The option Random Image will randomly change the order of the displayed image the moment when the user is checking the results. This function is useful when you have a huge image set. That is why I will disable it. If I click on Preview icon, an external window will be opened which contains the generated images, and it displays one by one in the order how the auto-labeling tool created them. You can appreciate that both annotations were correctly applied over each object. Above the annotation, the name of the class and the visible percentage of that class have been displayed. Don't worry, this information won't appear in the real image. It has been displayed in this part with the objective to analyze if the annotations were correctly configured. As you can see, the classification of the classes, the direction of the DL angle, as well as the shape of the mask were placed rightly over the objects. But this is just a simple case where we have few objects. Let's check other image where we can appreciate a more difficult scenario with the objects located in a clustered environment. You can press any key of the keyboard to have the view of a different image. Notwithstanding the annotations were properly established, when the object is covered by others, then the annotation has been divided into different parts. It will give us problems the moment when we conduct the training for the AI. It's much better to consider only the biggest visible area of the object to place the annotation. You can close this external window by clicking on the X icon located in the top right side. I just need to select the biggest area in the output mask function to fix the problem. Now I need to check the annotations again, and as you can see, we have only one annotation for each object despite of how occluded it is. All the settings were perfectly declared. Thanks to the thing that we have generated only 10 images, we have found and solved all possible errors. As I mentioned before, once the image set was generated, it's an obligation to modify the structure of the files so as to be able to load in AccuPick. There are two ways how you can save the modified files. The first way is by saving them in the default directory of the project. To be specific, inside the Solomon data folder, which is empty. For that, I need to click on to AccuPick 3D icon, and another window will ask me if I want to proceed. Just click on AccuPick 3D Converter. A similar window like the one we saw when we were generating the image set will appear. It will display the remaining time for the converting process. If I open the Solomon data folder again, now you will see that it contains 10 images plus 2 extra folders which have the information of the annotations. Despite the number of the images you have converted, you will always have the same 2 extra folders. You can simply copy these files and paste them inside the image folder of the project in AccuPick. But there is an easier way to avoid this process and directly put the image set inside the folder where AccuPick will use it to load them. That is the second way, where you have to copy the path of the folder named as image and paste it instead of default. To obtain the path, I need to open the project in AccuPick and go to the recognition block. In AI tab, right-click over the instant segmentation icon. An extra window will appear. Select the option Open Folder and automatically the folder where AccuPick used to store the images will be opened. Double-click on the image folder and you will see the initial set of images we have captured as a preparation for the auto-labeling tool. The consecutive steps are extremely important to load the images in the correct way in AccuPick. First, close AccuPick program. To be 100% sure that AccuPick is not running in the background, please check it in Task Manager. If AccuPick is not listed in the Background Processes section, then we are sure we can continue without problems. In case you have found AccuPick in this section, then select it and click on the icon End Task. Our objective is to store the images we are going to obtain from the auto-labeling tool directly in this folder. Therefore, we have to clean completely the current files that this folder contains. But instead of eliminate them all, we can give a better usability of the image set. Select all the images that contain the objects inside the bin. Do not consider the image of the bin empty and cut them all. Open the folder where you have the project of the auto-labeling tool and paste the images inside the template folder. Don't forget that we haven't finished to clean the image folder, so just delete the remaining files which are not going to be useful anymore. Finally, we can copy the path of this folder and proceed to paste it to the Save To section. Be sure that the function Use Template Images is enabled. This function allows to use images of the real object that we have been previously copied to the template folder to make the generated images as closer to the real as possible. We don't need to do more tests because we are sure that the results of the quality of the images as well as the annotations are the most optimal. That is why I'm going to generate a big image set where I will simulate all possible scenarios I will have in the real situation. For that reason, I will generate 2000 images. Remember to keep the variability of the objects that goes from 1 to the maximum number of items you will have in the real scenario. Now we can start the generation process. And lastly, the converting process. If I open the image folder, you can appreciate that it contains the set of 2000 images generated from Blender and ready to be loaded from AccuPick. The last step is to open the project in AccuPick program. Go to the recognition block. In AI tab, select the training section and click over the icon with the cross. Select the file inside the folder and use the shortcut Ctrl-A so as to select the complete items inside the folder, including the annotation and segment image folder, and click on Open icon. This action will bring the complete image set to AccuPick. This process may take several minutes. Just be patient until AccuPick loads them all. Excellent! Now you are free to continue with the training of the AI in AccuPick, in the same way as you have appreciated from the tutorial videos and the manual of AccuPick.